Almost just thinking about it from the perspective of abstracting the idea of taking advantage of people to the point where you have somebody who writes a virus but doesn't actually give anybody the virus. Somebody else who gets a message to somebody actually delivers the virus but doesn't do any clicking. And then, us consumers reading the email, thinking it's actually from our boss, coworker, whatever, clicking it. Where has the crime occurred? I don't know. So it was a pretty interesting presentation. If you happen to, I encourage you to watch all 5 hours of presentations. It was exhilarating. But if you were to target a presentation, the second to last one, so around hour, 4.5 or so, that one had that very interesting 5-minute little video that was fairly fascinating. So if you were to try to compress it down to 5 minutes, that might be an interesting one to watch. Okay, so let's catch up on homework stuff. So we had homework that was due on Wednesday and then another assignment that was due today. What was due Wednesday? What was that question? What did it ask us to do? FizzBuzz, but just the logic for a single pass? Okay. And then the Friday one was put it into a function?
No, it was in a loop.
Okay, in a loop. Do we have a function one yet? Due Monday. Okay, so we're going to talk about functions today, right? All right, good. All right. So, again, human beings solve problems using memory, asking questions, and repetition. So we're going to remember a number. So I'll say A is equal to 7. Some of you might have looked at the book and you read something in using input and asked the user to enter a number. That's fine, but we have a number. We've remembered a number inside of a variable named A. Now we want to ask some questions. For FizzBuzz, let's see, what is it? Print out FizzBuzz if a number is evenly divisible by 3 and 5. And it prints out Fizz if it's evenly divisible by just 3. Buzz if it's evenly divisible by 5. And then just prints out the number otherwise. Right? Okay. So we're going to ask a series of questions. We're going to ask if A, when divided by 3, has no remainder, and A, when divided by 5, has no remainder. Notice here that you can't say this. Here, I'll just write it on another line here. You can't say A mod 3, let's see, how would somebody write it? Equal to, how would somebody write that incorrectly? Maybe something like, and A mod 5 equal to 0, something like that. You have to explicitly say the question both times, the Boolean expression. This is a Boolean expression that boils down to a single value of true or false. This is a Boolean expression that boils down to a single value of true or false. This whole thing is a Boolean expression that boils down to a single value of true or false, because we have the and. So in order for this whole thing to be true, both sides need to be true. All right. So if this is a true statement, then we're going to print out FizzBuzz, right? And remember, indenting underneath the if says this belongs to the logic associated with this if. So only if this boils down to true will we do this. If we forget to indent it, then that happens always. This is no longer linked to that if. All right. Else if A mod 3 is equal to 0. Now, only in an if-else if structure, only one thing can fire. Several of you were asking some questions. You may have had something like this. You asked a second question. And then you would say print fizz, like that. And then you were wondering if you gave a number like 15, why it was printing out FizzBuzz and then also printing out fizz. It's because we're asking a second question here. We're saying, is the number you gave us, in this case 7, evenly divisible by both 3 and 5? If it is, print out FizzBuzz. Then you ask a whole separate line of questioning, asking if that number is evenly divisible by 3. If it is, print out Fizz. So for a number like 15, this would have printed out 2 different things. I'll go ahead and run this. We get our FizzBuzz and we get our Fizz, which isn't necessarily what we wanted, right? We wanted it to print out FizzBuzz when it was evenly divisible by both, Fizz when it was evenly divisible by 3, Buzz when it was evenly divisible by 5, or just the number if it wasn't evenly divisible by either of those. So notice the difference here between an if and an else if. Now only the FizzBuzz prints out, because only one of these things can fire, and it goes in the order from top to bottom. All right, so if it's evenly divisible by both, print out FizzBuzz. If it's else if it's only evenly divisible by 3, print out Fizz. Else if it's evenly divisible by 5, print out Buzz. And then our catch-all else, print whatever our number was. So for 15, it'll print out FizzBuzz. For 6, it'll print out Fizz. For 10, it'll print out Buzz. For 11, it'll just print out the 11. See how that's working? All right, questions about that logic and why it works that way. Go ahead.
What's the difference between the else and the else if?
This is effectively saying otherwise.
Okay.
So these are saying otherwise ask another question. Otherwise ask another question. Otherwise just do this.
Okay.
So if this fails and this fails and this fails, this is your catch-all. Now you don't need to have an else. If you don't have an else here, then your output will be nothing. Because we fail this if, we fail this else if, we fail this else if, and our program doesn't say to do anything. Make sense? Some people maybe did something like this. You printed out A there at the bottom, and now since this guy's no longer linked with this if-else structure, A always prints. So we printed out an 11 there, but if I go back to a 10, we'll print out the Buzz followed by the 11, or followed by the 10. All right, so this line right here is no longer linked to this structure. Now, if I just indent it, that's the only difference I make there. Now it'll print out the number as associated with this Boolean expression, but none of the other ones. So now I'll get Buzz and 10 for that. But if I switch this to a 9, now I'll fall into this guy right here. I'll just get Fizz. I won't get the number. There's my Fizz. All right, understand how the logic's working? Go ahead.
Is it important which order you have the statements before they
In this case, it would be. Because in this case, if I swapped out, if I say A mod 3 is equal to 0, and then I do that, my second one, for instance, and then I give myself a 15, which we expect to get a FizzBuzz out of, right? So a 15 is evenly divisible by both. We expect to get a FizzBuzz here, but we're accidentally going to boil down to true right there on the Fizz. So in this case, it did matter that we asked the question in, let's say, the wrong order, because once we got into this if, we never fire any of these other ones. Does that make sense? Now, that won't always be the case. In this particular problem we're solving, it happened to be the type of problem where some of the questions were subsets of the larger question. So this is kind of our most specific version of our question. So we're probably going to ask that first. Then we're going to ask the less specific versions of the question after that. so that we don't misfire early. All right, so we'll go ahead and put our else back in here. So that would have been solution for, that's the Wednesday homework. All right, any other questions about that code? So points of interest here is make sure you're using else ifs, not repeated if statements, because then multiple things can fire. This is a brand new line of questioning. This is a brand new line of questioning. So in this case, multiple things can happen. So if I change this to a 15, we get our FizzBuzz, we get our fizz, we get our buzz. Because this is true, so we're doing this. And then we're asking a brand new question here, and that is true. So we're printing out this. Then we're asking a brand new question here, and that is true. So we're printing out that. And this else belongs to just this if. So we're not actually printing out the number. That make sense? Or whatever. Okay. So then, let me get our else back in here. The homework for today was to what? Do all the numbers between 1 and 100,000, something like that, but apply this logic to it, right? So we want to now repeat this logic 100,000 times. So we need to do this in a loop, and we talked about that at the end of class on Monday. So we're going to repeat something, and just as a reminder here, I'll just put it after this. I showed you a for loop that takes a variable I in this case. Actually, I'm gonna take a variable A in range 1 to 100,001, because the way range works is it says start with this number, go up to but not including this number. And then if I print out A here, this will show each time through this loop, A will become a new number. It'll start off as 1, we'll print out a 1. Then A becomes a 2, we'll print out a 2. A becomes a 3, we'll print out a 3, all the way up to 100,000. Make sense? So if I start running this, we see we are watching A increment each time through. And what do we actually want to do with that variable? We want to put it through this line of questioning. All right, well, we got to fix some indentation here. All right, so notice that all of this stuff is indented underneath this for loop. So all of it now belongs to that for loop. So as we go through this for loop, and A is 1, A is 2, A is 3, A is 4, we are asking these questions associated with A. All right, I named it A here because I happen to already have my variable A being part of my question, the line of questioning down there. All right, so for the number 1, we'll ask these questions and come out with our answer. So in that case, it'll just print out a 1. Number 2, we'll ask the same ones. We'll get our 2. For 3, we'll ask the same ones. We'll get our fizz, so on and so forth. All right, so there's our FizzBuzz program for all the numbers between 1 and 100,000. All right, so we took the exact same logic from Wednesday and put it inside a loop that allowed us to repeatedly ask that question for different values. All right, questions about that? Okay. So the next thing we're going to look at, I'm going to introduce functions here, and then we're going to talk about some number conversions. So a function is a chunk of code that we write once and can call multiple times. Syntax for a function is def, it's a lowercase d, function name, open parenthesis, comma, delim, parameters, closing parenthesis, colon, indent, logic, 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 and then we'll say optional return. All right, so let's look at some examples of this guy. So the idea of a function is we might, let's say as we're writing our programs, we might have a certain chunk of code. For instance, for your homework for Monday, you might have this FizzBuzz logic that is crucial to your solution to your homework. And you might want to put that inside of a function so that whenever you want to ask the FizzBuzz question of a number, you can call that function, which is stored somewhere else in your program, and it'll apply FizzBuzz to it. That can be beneficial as, let's say you have this big long computer program and you're asking FizzBuzz up here and FizzBuzz a little bit farther down and FizzBuzz farther down. So you have 3 different areas of your program maybe that you're applying this FizzBuzz logic to for some reason. Rather than repeat your code in 3 different places, you can write it once and then just use it in those 3 different places. An advantage of that would be if you change your logic a little bit, you decide that FizzBuzz is no longer 3 and 5, it's now 6 and 12 or something like that. Well, 6 and 13, let's say. At that point in time, you could change it just in the function, and then all your other FizzBuzzy questions will now be updated because you're always calling the function to apply that logic rather than having to go and change your code in those 3 different places in your program. All right, so you might turn something into a function whenever you want to call that logic more than one time. So so one rule of thumb, don't write the same code more than once. All right, and this is a little bit loaded from the perspective of, you probably wouldn't write a function just to print a single thing. You would call the print function multiple times to print something. So if you have like 1 line of code, you probably would not wrap that into a function. Instead, you would just have that 1 line of code in 4 or 5 different places of your program, unless it just absolutely made sense to put it into a function. Generally, what we're talking about here is when you have some algorithm, some mathy thing that you're applying to a problem that you're going to repeat throughout your program. You put it in one place and then call it multiple times from that one place. Returning values. Some functions just do something and do not return a value. Other functions do something and actually spit out an answer. All right, so let's look at a couple of examples of this. This is why back here I said optional return statement. All right, so I might say def do something, and we'll have this guy take no parameters for right now. And what this guy will do is it will say for I in range 0 to 10, print I, something like that. All right, so now whenever we call the do something function, it's going to print out 0 to 9. Now at this point in time, this guy is an untapped resource. I've written the function, but I haven't actually called that function. If I hit play here, we see nothing happens. So down here, we're going to still write fairly simple programs. Eventually, you're going to have something that'll say like if _ name equals main. That'll be where your main method is. But so if you've seen some examples like that, that's fine, but don't worry about that for right now. So now I'm going to say do something. So I'll call my function. I wrote it once. Now I'm calling it once. So there's my 0 to 9. I can then say print hello world, and then I can call do something again. So now I wrote the function once, I'm calling it, then I'm doing something else, and I'm calling it again, for example. So I'm reusing that chunk of code. So there's my 0 to 9, and then my hello world, then my 0 to 9 again. That makes sense? Keep in mind that this function is not returning a value. It is accomplishing something internally and printing that value out. So I'm going to put another little slide here. Truth. Returning a value is different than printing a value. Those are different things. Okay, we're going to see that here in a second. Maybe in do something, I say int sum is equal to 0. And rather than print out I inside of here, I say sum is equal to sum plus the current value of I. And then in the end, I'll go ahead and print out sum. So what this logic does is it goes through all the numbers between 0 and 9, adds them all up, and then one time after the loop, notice this guy is not indented underneath the 4. Instead, it's after the 4 at the same level. So this will print out my summed up value exactly one time. Oh, that is not Python code. That is Java, C++, C# code. There we go. So there's my 45. There's my hello world. Remember, Python is a loosely typed language. We don't define the kind of value our variables are built to hold. So to define a variable, you just say the variable name equals the value. So there's my 45. There's my hello world. There's my 45. So when I call something, it's going to sum up all the numbers between 0 and 9 and then print it out once. As opposed to if I just indent that and do nothing else, now it's going to print the current value of sum each time it's going through that loop. All right? So we're getting the updated version of sum as it's going through there, with the ultimate final value being that 45. See how important that indentation stuff is? All right, so pay good attention to that. All right, so this guy right here is doing some stuff, but it's only printing that value out. Now, I can also choose to return that value. So let me not print it, and instead I'll return it. All right, so now I'll call do something, I'll print out hello world, I'll call do something again. The output of this program is just hello world. Do something is calling this guy, which goes through and stores inside of sum the summation of all the numbers between 0 and 9. Then I'm returning that value, but I'm not doing anything with it here. If I want to do something with it, I can store it in a variable, for example, and then I can choose to print out answer. I could also choose to just print it directly. So there's my 45 where I caught it in answer, then printed out answer, and then this is my 45 where I just printed out the returned value. Go ahead.
So what's the point of the return command then?
it gave me the answer. When I returned it from here, this guy fired out that answer, and I was able to do something with it.
Okay, so it doesn't just do that by automatically without the return?
No. Yeah, so if I don't put that in there, for example, and I try to print out the thing, this function returns something called none. It's a null function. So I'll get none printed out twice there because my function did not return a value. All right, so if I want something to come out of this function, I have to specifically return that value. Now another return makes a function immediately end. Note that return does not require that we actually return a value. I'll show you what I mean by that here in a second. So you can use return just to end a function. So for example, if in here, I want to just say return. So even though this loop is going to attempt to go through 10 times for 0 through 9, the very first time through, I'll add to my sum of 0, my first value, which is 0. But then I'm just saying, you know what, function, go ahead and die. I didn't return a value there. I'm still going to get none and none because my function did end right here. If I want to prove that, I'll go ahead and just print out sum. And we're going to see that sum is going to be 0 because 0 plus 0 is still 0. So that's my value of sum. And then I returned. It didn't go through multiple times. Go ahead.
Is that the only way to end a function, or is that just...
That's the only way to immediately end a function. A function can also end just naturally when you hit the last line. But if you want to kill a function off early, maybe you're asking some question that if the user typed in exit or something, you want your function to end, don't do any more logic, you could just say return and make it end. Now I could also, return LOL or something like that if I want to return a value just for some reason. So you can optionally give it a value to return. But the return statement itself does not require you to give it a value. The return statement itself makes a function end, and optionally it allows you to spit a value out of the function. I usually would refer to it as this guy boils down to a value. It boils down to the value of whatever that function returns. Okay, so in this case it boils down to LOL because that's what I return there. If I don't return anything, my function still boils down to something. It boils down to none, nothing. The function naturally ended or ended without me returning a value, and therefore I'll get a none out of it. But internally, my function still printed out the value of sum 10 times. So there is a difference between printing something inside of a function and returning a value from a function. Very important concept, because sometimes on a test or something, I'll ask you a question to write a function that takes these 3 parameters and returns a value. And students will constantly print something out inside the function instead of returning a value. They are not the same thing. And let me give you an example of that. Let's say we wanted to write a function called addNums that took in an A and a B, 2 parameters. And I'm going to return A plus B. That's what this function does. It returns A plus B. And I say something like answer is equal to addNums 2 and 7. And then I print out answer. I expect answer to be equal to whatever addNums when I pass in a 2 for A and a 7 for B returns. Because this guy takes 2 plus 7, which is 9, returns that value. This guy will then boil down to that value, which I'm storing inside of answer, then I'm printing out answer. So I pass 2 and 7 in. 2 plus 7 is 9. Return a 9. 9 gets stored inside of answer. Then I print out whatever value answer holds. So this will give me a 9. Similarly, I can use that exact same function a second time, but I can pass it a 26 and a 71. 2 different inputs, but same function. So it gives me a 97. So now I have this function that knows how to do something. It happens to just add some numbers together, and it spits out the answer. And then I can choose to do something with that answer. If I don't print anything here, I'm gaining those answers, but I'm not outputting anything from my program. Print gives you output to the screen. Returning a value gives you an internal answer that you can do something with. Make sense? Okay. And, we certainly can do something like we could say for I in range of A to B. And then I can print out I here or something like that and not actually return a value. So now add nums is a little bit misleading because I've named my function add nums, yet it does no adding. It just spins through all the numbers between whatever A is and whatever B is and prints out those values. So this is going to print out all the numbers between 2 and 6 for this first one because it's non-inclusive to the 7. And the second time it'll be 26 to 70. See how that's working? Now what if I say 71 to 26? Our intention might be to go from 71 down to 26, but we see that it actually does not run. Because we're saying go from 71 up to 26. Inside there, a question is being asked. Is the current value of I, which starts off as 26, or I'm sorry, which starts off as 71, is that less than 26? It's not. So we're done. This loop just immediately ends. It fails that first question. If I do want to step backwards, I can say -1 there, and that will make it go in reverse. But then we'll fail on the first one. So the first one here didn't execute because 2 to 7 is 2 greater than 7? It's not. So we cannot step backwards. But if I flip these guys around and I say 7 and 2, now it'll just walk both of them in reverse. That make sense? So you can give it a third statement here, a third parameter to the range function called step that tells you how do you want to walk through this. I can walk by -3 if I want. That'll take size 3 steps. 56, 53, 50, 47, 44. So you can choose what you want to put in there. Okay? So we would call this for loop a tool that we use for going through numbers in a range, either forwards, backwards, and taking steps of whatever size we want. The default is a step size of +1. All right, questions about any of that stuff? All right, so let's start looking at number conversion stuff. Let's see, have we already done? Okay. So we're going to talk about a couple different things. We're going to have something called size/speed, and then we're also going to have something called magnitude. Except we need to spell that a little bit better. Whatever. All right, so we're going to create our chart for size/speed. I have two of these guys here. All right, so we have our computers operate in bits, right? So we have 1 bit. The next thing is we have something called a kilobit. We haven't talked about this yet, right? We haven't talked about kilobits, megabits, gigabytes, any of those things? All right. So how many bits are in 1 kilobit? Go ahead. 1,024. So we have 1,024. Well, we have 1 kilobit, small b, is equal to 1,024 bits. Next is 1 megabit, small b. That's 1,024 kilobits. Next we have 1 gigabit, small b, is 1,024 megabits. And just for the sake of completion, since I'm going to go that far on the other one, 1 terabit, small b, is 1,024 gigabits. Now we have something called a byte. How many bits are in 1 byte? 8 of them. So 1 byte is equal to 8 bits. 1 kilobyte, big B, is equal to 1,024 bytes. 1 megabyte, big B, is 1,024 kilobytes. 1 gigabyte, big B, is equal to 1,024 megabytes. 1 terabyte, big B, is equal to 1,024 gigabytes. All right, see how that's working? To go from bits to bytes, we have a scalar of 8. And then it's always 1,024 to get to your next bigger one. And then we start talking about kind of consumer awareness type stuff. How many of you have internet at home? What's the speed of your internet? Computer science majors, we should all know the speed of our stuff. Anybody know what speed their internet is? What are you paying for at least? What's somebody paying for? 217 what? Megabits per second. All right. So a lot of times if you have a cable modem, so we'll call it the cheaper internet from a cable company would be like 200 megabit per second. Small b. Okay. A lot of times the commercials, you know, they don't even put the bits or the bytes on there. Just call it meg. 200 meg internet, right? So what's your maximum download speed if you're downloading a file with 200 megabit per second? It's not 200 megabytes per second. So this is 200 divided by 8. So your maximum download speed is 25 megabytes per second. That makes sense? I divided that guy by 8 to get me to 25 megabytes per second. Now, when you're downloading files, do you always get 25 megabytes per second? Anybody have faster internet than this? What do you got?
Did a speed test a few days ago and I was getting like 470 down.
Okay, so you're probably paying for 500 or possibly 768 megabits. Companies starting now to offer gigabit internet, which is 1,024 megabit or 128 megabyte internet. Okay, but at 25 megabytes per second, even if we just use this 200 megabits per second thing, you'll rarely get a download speed of 25 megabytes per second. Why is that? Aren't you paying for it? Huh?
It's like based off the server you may be downloading it from, and also sometimes maybe throttling it based
Okay, yeah.
on usage.
So our home-based internet is called asynchronous internet. So download speed is typically much faster than upload speed. Okay, so when you have your internet at home, your consumer-based internet, most of what you're doing is downloading stuff, streaming Netflix, downloading attachments for email, things like that. Very little of what you're doing is uploading. So the only time you're really uploading is when you're like putting an attachment on an email or sending a file over the internet, like uploading to Dropbox or something like that. What the internet company is really trying to prevent you from doing is running servers out of your house. All right. So the reason you don't get 25 megabytes from often from wherever you're downloading is your download speed is limited by someone else's upload speed. So when you're downloading a file over the internet, the maximum speed you can download it at is whoever you're downloading it from's upload speed. Now, chances are you're downloading it from not somebody's home-based internet, but a commercial source, Google, Apple, whatever, Microsoft for updates. But even then, you're not getting 25 megabytes per second that often. Okay, why is that? Well, even though we assume Microsoft's internet connection, internet pipe is much, 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 much larger than we have in our living room, they're dividing it. How many people are hitting Microsoft's or Google's website every second? Round it down and say a lot. Okay, so you are dividing their total upload speed by a lot, and that's what you're going to be capable of getting. That's where some of the newer technologies like BitTorrent and things like that come from, where we can now distribute the bits that you're downloading across multiple servers. So maybe if I'm downloading an update to a game, maybe I get some of the bits from you, and some of the bits from you, and some of the bits from you. So I'm using your upload speed, and your upload speed, and your upload speed. So you have a whole bunch of different people, and you're using a little bit of their upload speed, and then maybe you can start getting closer to maximizing your download speed of your connection. Make sense? So this is one way we use this megabits, megabytes, things like that. And as a consumer, we want to know, as a technology-focused consumer, we want to know what we're actually paying for. When they say 25 meg internet, it's not this meg, it's this meg. Make sense? All right. Similarly, if you go out and you get a 3 terabyte hard drive, that is 3 times 1024, which is 3,072 gigabytes, which is 3,145,728 megabytes, so on and so forth. Times 8 is 25,165,824 megabits. All those are equal numbers represented in different scales. All right, so you should be able to memorize this chart. Should be pretty easy to memorize. This is a scale of 8 off of this one, then everything is times 1024 on the way down. So you really only have to remember 2 values. And then the different names, bit, kilobit, megabit, gigabit. All right, so I'll just label this guy internet speed. Now I mentioned, so we have size and speed. We just talked about that. The other thing is magnitude. And this comes down to number bases. Now humans, we like base 10 or decimal because we have 10 fingers, 10 toes. It's kind of that's in our wheelhouse. All right. What base do computers like? Binary. Base 2. Binary. All right. So when you think about number bases, what you're really talking about is the language of numbers that you have to work with. So the digits that we have in base 10, our digits are 0 to 9. Those are the digits that we use to make up all of our numeric values. That's the language of our base 10 number system. The bits used in binary are 0 to 1. What other popular numeric bases are involved in computers? Hexadecimal. So we'll say computers, hex, that's base 16. I'll call it base 16. Hex, these are called hextets, and that is 0 to 15 are the legal hextets, and actually it is 0 to 9 and then A through F. Those are the hextets. Any other base that computers often use? One last one. Base 8, octal. The octets for octal are 0 to 7. So a pattern we want to notice here is base 10, legal digits are 0 to the base minus 1. Base 2, legal digits are 0, well, legal bits are 0 to the base minus 1. Hexadecimal, legal hextets are 0 to the base minus 1. Octal, legal octets are 0 to the base minus 1. Starting to see how that works? So whenever you have a base value. Now, does base 13 exist? Sure. We don't have a name for it. There's probably a mathematical name for it, but it's not a commonly used thing, so we haven't assigned a name to it. But the legal values, the legal things for the language would be 0 to 12 for base 13. That makes sense? All right, so this is our starting point. Next time we're going to talk about converting between decimal and binary, binary to decimal, decimal to hex, hex to decimal, yada, 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 yada. All right, I'll see everybody on Monday. If you didn't see on Slack, we're doing and this applies to a lot of you from 175. On Tuesday night, around 5 o'clock over in 109, I'm going to run a little thing where I'm going to help you get your Raspberry Pis connected to like your laptop, where your laptop powers it, and then over Ethernet you can remote into your Pi and have a full graphical Linux similar to your virtual machine if you want to do that instead of a virtual machine. Then we're going to watch the movie The Art of Self-Defense, which is where the belt thing comes from. A lot of people missing belts today. It's got to be on. It's got to be on. Or you give it back.
I have a question about the homework.
Yep.
So the way I interpreted it, you said apply the logic from 1 to 100,000, right?
Mm-hmm.
The way I